Hi, this is the professor, and today we're going to talk about right triangle trigonometry. The objective of this video is to find the value of trigonometric functions of acute angles. Let's look at the right triangle right now. As we see that C is the long side of the triangle, which is called the hypotenuse. It's always represented by C, but there's other letters that it can represent, and we'll talk about that later on. We have the B and the A sides, which are considered as legs. Now, you notice theta here on the triangle. Theta, in fact, can be on this position or this position of the right triangle. However, B, representing the opposite side, means it's the opposite side of the angle here. B is here and theta is here, so it's opposite side of the angle. A is represented as the adjacent side, which is right beside the angle, theta. Now, let's talk about the 6 ratios of the length of the sides of the right triangle, which are called trigonometric functions of acute angles. And they are defined as, we have the function name represented as sine of theta, cosine of theta, and tangent of theta. The abbreviation is sine theta, cosine theta, and tangent theta. Now the values, and we'll get into this in a minute, you have B over C, A over C, and B over A. Now, let me just say, the B represents the opposite side, and the C represents the hypotenuse. So that's how this ratio is set up. For cosine theta is the A side, which is the adjacent side over the hypotenuse, which is represented by that ratio. Also, tangent theta is tan theta, which is represented by the opposite side or the adjacent side of the triangle. Now, as we go over here and look at these function names here, these are considered reciprocal identities, and we'll get into the explanation of those as well. Here, they're the reciprocal. So, if you have B over C for sine theta, then the cosecant of theta would be C over B. It's reciprocal, right? And the same goes for cosine, as you have the adjacent side over the hypotenuse represented by A over C. Secant theta is represented by its reciprocal C over A, or hypotenuse over the adjacent. And tangent would be opposite side over the adjacent side, and cotangent will be its reciprocal, which is the adjacent side over the opposite side, if you will. Now, let's go over here to the board, and let's look at how the trig identities are also represented and written out in words. Sine meaning opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, and it's always represented by what you can say to remember is so katoa. This is like a famous saying to be able to remember the ratios of each of the basic 3 trig identities. Now the reciprocal identities, as represented with the letters here written out, is the reciprocals of the above basic trig identities. Cosecant with hypotenuse over the opposite side, hypotenuse side over the adjacent side, representing secant theta, and cotangent, which is the adjacent side over the opposite side. Now, it also can be represented as cosecant here. Cosecant also equal 1 over sine theta. Secant theta can also be represented as 1 over cosine theta. And also cotangent is represented by 1 over tan theta. Now, let's do a problem. let's do a problem here. We want to find the value of a trigonometric function, which the triangle here is displayed, and we have 5 at C representing the hypotenuse C equal to 5, and we have A, the adjacent side, equal to 3. And the opposite side, B, is unknown. We don't know what that side is. However, we use the Pythagorean theorem. A squared plus B squared is equal to C squared. So basically, you plug in your values for A, which is 3, and also for C, which is 5. And of course, B being unknown, you bring the B down, and of course, you simplify, or you do the math and simplify your expression, and you have to solve for the unknown side, which is B. Right? So in this case, as we put 3 here, 3 squared plus B squared is equal to 5 squared. It will be represented with 9 plus B squared is equal to what? 25. Now, notice what I do here. We got 9 plus B squared here is equal to 25. So what we're going to do is some simple algebra, and we're going to take, to isolate the variable, B squared, we want to take negative 9 to both sides, and of course, B squared is equal to 16. Now, a lot of students make a mistake, and they leave this as such. Remember, we have to solve for B, not B squared, say. So how do you solve for B squared? Well, what we do, we multiply 1/2 to the exponent, and what you do to one side of the equation, you must do to the other side. Meaning 16 to the first power is 1, 16 to the first power times 1/2. So, which is 1/2 here. So 1/2, any number to the 1/2 power is considered a square root of that particular value or number. However, after we do that, we just bring this down, and B we solve for, it cancels out. 2 times 1/2 is 1. So it would be B to the first, so it would just be B, is equal to the square root of 16. The square root of 16 is 4. So B is actually positive 4. Now sometimes, usually we use, when we represent square roots, it's plus or minus, but since it's distance could never be negative, so B is positive. So this is how you basically find the side, the opposite side, or the side that's being exposed that we don't know. This is how you find, using the Pythagorean theorem, to find the side that's not known. So B being 4. Okay, so let's go and let's use the trig identities to find the values of the trig identities. So here with sine theta, which is represented by what? The opposite over the hypotenuse, what should we do? Well, we should use, what's the opposite side? The opposite side, we found that, didn't we? So the opposite side will be, we can represent it by, we can abbreviate OPP divided by HYP, can't we? Which is the opposite over hypotenuse. Now we'll say that sine theta will equal what? 4, what's the hypotenuse? 5, 4 over 5. So this is your representation of the exact value for that trig identity, right? So let's do cosine theta. Cosine theta, which is adjacent, we're going to abbreviate that over hypotenuse. Here we have the adjacent side, which is 3. And what's the hypotenuse? The hypotenuse is 5. So cosine theta will be 3 over 5. What else? Tangent theta. Tangent theta will be represented with the opposite side over the adjacent side. So the opposite side, which is 4, over the adjacent side will be what? 4 divided by 3, as we see. Now, we're not quite done yet, because what I would like for us to do is use the reciprocal identities, or should I say, the other three basic trig identities, which are the reciprocal identities, except you can represent it by a hypotenuse over, cosecant representing the hypotenuse over the opposite side, and the secant side, secant theta, which is the hypotenuse side over the adjacent side, and cotangent, which is the adjacent side over the opposite side, excuse me. And you can also, if you will, you can use this identity where it's basically you get the same values if you use this and this, but here you can also take this and also take 1 over sine theta, which is represented by 4/5, and actually do the division of fractions. However, we can do this, and also we can do this. I can show you how both of these both of these identities that are set up, or the reciprocal identities written in different ways, I can show you that no matter which way you do them, you should come up with the same value. So let's see. First, let's do this. Let's actually do the written out hypotenuse over the hypotenuse side over the opposite side. Let's do the hypotenuse side over the adjacent side, which is represented by secant theta. And let's do cotangent, which is represented by the adjacent side over the opposite side. Let's do that first. So everybody understands that we have these values that we found through the basic trigonometric functions. Okay, so here, if you will, I think I should go over to the other side of the board, shouldn't I? So we'll go over here. Now, feel free to copy down the notes if you can, and also rewind the video if you can, and get any information that you need. And we also will be doing more videos on this as well. So we'll just erase. Okay, and we'll write out the basic trig values that are represented here. So sine theta was actually what? Sine theta was actually 4 over 5. Cosine theta was what? Cosine theta was 4 over 5. Let me see, 4 over 5, no, not 4 over 5, 3 over 5, excuse me. 3 over 5. And tangent theta was 4 over 3. So let's look at this now. So let's do the cosecant identity. The cosecant identity is hypotenuse over the opposite side. And so what we do here with the reciprocal of this, we'll just switch this over to now, it'll be what? 5 over 4. Everybody see that? How about the secant side? Secant identity. Secant identity will be hypotenuse over the adjacent side. Well, let's go ahead and just abbreviate this as well. I'm sorry. We'll abbreviate this. And when we do this, what do we get? We also get 5 over 3. How about tangent, or cotangent that is? Cotangent theta. This is secant theta. Cotangent theta. Cotangent theta will be the what? It will be the adjacent side over the opposite side. Adjacent side over the opposite side. And that will be represented with what? The value of 3 over 4. Now, we see how these identities, right, works as opposed to with the first three basic identities. Now, let's do the other representation of trig reciprocal identities of these last three trig functions. And this being cosecant, which is what? It is going to be what? 1 over sine theta. Secant theta will be 1 over cosine theta. And then we have what? We have cotangent theta, which will be 1 over tan theta. Now, all we have to do is go back and get these values here and put for here, for example, 1 over sine, which is what? Sine theta, which is 4 over 5. Remember that? And we will get the same value, I bet, because 1 divided by, and we can write, this means division, right? A lot of students don't like fractions, but we can't live without them. It's a part of mathematics. So 1 divided by 4 over 5 is going to equal to 1 times 5 over 4, right? Whenever you're dividing fractions, you're going to do what? You're going to change the operation symbol to multiplication and take the reciprocal of the second term. And this will be what? 5 over 4. So look, we get the same thing as the actual written out reciprocal identity here. See, it's the same thing. Also here with secant theta, which is 1 over cosine theta, where's the cosine value? Look at the cosine value here. And then you say secant theta is equal to 1 over what? 3 over 5. And you do basically the same thing here. You'll say 1 divided by 3 over 5. And then you say 1 times, change the operation symbol to what? 5 over 3, and you get what? 5 divided by 3. So you get the same value as the value you get here, being represented with 1 over cosine theta, with the same written out value, reciprocal representation of the reciprocal identity, 5 over 3. So you're getting the same value, and as we come back to here, we have what? Cotangent theta, which is 1 over tan theta, which is 4 over 3 here. And so here, will we get the same thing here? We should. 1 divided by 4 over 3 is equal to 1 times 3 over 4, and we still get the same value, 3 over 4. You see this? So I'm sure you will be able to find values, find the values of your trigonometrical functions, the exact values represented by the exact number. Approximations are like decimals and stuff, and we'll get into converting degrees to radians and radians to degrees and the exact values for that. But also too, in later videos, we hope to show you some more complicated problems using radicals. Radicals, and learn how to what? If the radical is in the denominator, you have to simplify it by rationalizing the denominator. That'll come into play with later videos. Right now, I hope this helps you out really good, and I will give you information in which you will be able to contact me, and also there will be more videos to come. This is actually our first video, and so we plan on to do many more videos to help the students become successful. Thank you.